So this is what it looks like in your booklet. So as I said, age and height, you need to flip them around or just put arrows to reverse it. So with that being said, age is going to go along the horizontal axis and it is in years. On the vertical axis, we have the height, which is in centimetres. Okay, so the age ranges from 2 to 11. Okay, so we're going to start at 2 and go up to 11. Now you could have used any scale, you could have gone up by 2s, you could have just gone 2, 3, 4 without missing a gap. It's completely up to you, however, just make sure that you are consistent in your spacing and what you go up by. So with the height goes from 87 to 145. So again, I'm actually going to put in one of these little symbols to say that I have skipped part of the scale and I'm going to start at 85. I'm going to go up by 10s. So each block or each square represents 5. Okay, so we're ready to start doing our dots. So the first child who was 2 was 87 centimetres tall. Second child who was 3 was 93 centimetres tall. Third child who was 4 was 103 centimetres tall. We had someone who was 5 and they were 110 centimetres tall. 6 is 118. 7 is 121. 8 is 128. 9 is 134. 10 is 138. And lastly, the 11-year-old was 145 centimetres tall. Okay, so we've got all our children, all our dots on there. Now we're going to actually talk about what we can see. So the first question says, draw the scatter plot using the above table. Yep, done that. Describe the form of the association. So remember, the form is it linear or non-linear? Now looking at this forms a pretty good straight line, okay? So we would definitely say that this is linear form. Describe the direction of the association. So we can see that going from left to right, that our dots go up in a positive direction, or they're increasing. So we would say that this has a positive direction or positive gradient of the association. So as the age increases, there's an increase in height as well. Describe the strength of the association. So we said we've got strong, moderate, or weak. So the closer it is to a straight line, the stronger the relationship. So this is a pretty good straight line. So we could definitely say that there is a strong relationship or a strong association between the two variables. Number 5, predict the height of a student who is 12. So someone who is 12, be roughly over here, going upwards, following the trends that we sort of see there. I would say, and again, this is a predict question, so your answer might be different to the person next to you, okay? So roughly going off what I can see, I would say they're about 148 centimetres. But again, that's going to be different for you, okay? Number 6, what is the dependent and independent variable? Okay, so you have two variables. One's described as being independent and one is dependent, okay? Now, the dependent variable is always represented on the x-axis. So independent is always on the x-axis. Dependent is always on the y-axis. Now we can see from our graph, age is independent, and height is dependent. Now the question is why? Why did I change my order up here so that age was independent and height was dependent? Well, if we think of it and we say it both ways, does age depend on height? Or does the height depend on how old you are? Okay? Now, it didn't make sense to me to say that age depended on the height. That doesn't make sense, okay? So that is why I reversed my two variables in my table, okay? What made sense to me was that how tall you are depends on how old you are, okay? Particularly when you're a child, maybe not so much when you're older, okay? So as you get older, you generally get taller, okay? The older you get, the taller you get, okay? So in terms of what is the dependent and the independent variable, well, the dependent variable is going to be the height, and the independent variable will be the age. Okay, so the independent variable is represented on the x-axis and is not affected by the other variable. The dependent variable is represented on the y-axis, and it is the output or the answer and is dependent on the other variable. Okay, so height depends on age. Okay, all right, so that is that example done for using a bivariate scatterplot. So as I said, 3 things you've got to discuss: the form of an association, so is it in linear form or is it non-linear form? The direction of the association, so does it have a positive, is it increasing or is it decreasing, so is it positive or negative? And the strength of the association, strong, moderate or weak. So obviously remembering that the stronger, the closer the dots are to form in a straight line, the stronger the relationship is. Now, you will be doing exercise 6B, which is page 234 in your textbooks. Questions 1, 2, 3, 5 and 7. Okay, and I will post up the next lot of work on Monday for you guys. So good luck. Don't forget to submit your assignments in on Friday by 3:15. Bye.